Hello students, welcome to part 3 of the chapter Electrochemistry. And in the last part we have seen or we have introduced Electrochemical Series. So in Electrochemical Series is a list of half cells or electrodes that is placed in their decreasing order of electrode potential. That means each half cell has a potential called as electrode potential. As we go down, that electrode potential decreases. So maximum electrode potential is for F2 and minimum is for lithium. When the potential increases or the electrode potential increases, they can act as cathodes. So in a cell, there will be two electrodes. One will be cathode and one will be the anode. Cathode will be the one with higher electrode potential. I am picking one electrode, Cu 2 plus Cu. So electrode can be represented like this. First the oxidized part, vertical line, and the reduced part, which we have seen in the last part. So what does this mean? Copper is dipped in copper sulfate solution. Copper is dipped in copper sulfate solution. But if you look into the list, you will see that there are certain electrodes or half cell that doesn't have metal. For instance, this electrode H plus reduced to H2, that is hydrogen electrode, doesn't have metal to dip in its electrolyte. So there are half cells without metal electrode, and one example is this hydrogen electrode. Hydrogen electrode, if it is in its standard form, if all the species involved in this electrode is having a concentration of unity, then it is called standard hydrogen electrode, or in short SHE. Standard hydrogen electrode, or in short SHE. So how can we solve this? In this case, we use an inert electrode like platinum, or so these metals like platinum or gold are less reactive, so you can use it, and this inert electrode will allow gases to pass on its surface into the electrolyte. So they will not take part in the reaction. At the same time, it will help gases like H2 to pass onto the electrolyte through its surface. So let's see the design of SHE. SHE has a beaker in which it has the electrolyte, that is H plus of 1 molar concentration because it's standard condition, and into this beaker a inverted tube is dipped, to which hydrogen gas is bubbled. Its concentration also is 1 bar. And at the end of the tube, bottom end of the tube, a wire that is connected to the other electrode possesses platinum foil. At the end of the tube, the wire that is connected to the other part or other end of to the other half cell contains at the end a platinum foil, and this platinum foil is coated with platinum powder in order to increase the surface area so that the gas can easily come out of this tube. On the surface of this platinum, gas bubbles will react with H plus, or will transfer electron with H plus. That transferred electron is received by platinum and will pass through this circuit, through this external wire. So the purpose of platinum is a part of this electrode, but without taking part in reaction. So when you represent this electrode, platinum must also be represented like this. So we have the oxidized part, then the reduced part, and platinum. It is the reduced part, that is gas that is interacting with platinum. So the interface is between H2 and platinum. Interface should never be between H plus and platinum, because platinum is supporting H2 gas. So whichever part the metal is supporting, the interface must be between them. Platinum is supporting H2, so the interface is between them. So reduced part, since it is not a metal, you had to use inert metal like platinum, and it should be shown in its electrode notation. So you have half cell that is having metals that take part in the reaction, and you have electrodes or half cells that is having electrodes that do not take part in the reaction. So this is called active or reactive electrodes, and this is called inert. Platinum electrode is called inert electrode. So let's see how we can represent such an notation inside a cell. I am considering a cell which has two half cells, that is highlighted here, She and magnesium electrode, standard hydrogen electrode and magnesium electrode. From the list it is very clear that electrode potential of She is higher than magnesium. That means here cathode will be She. So She acts as cathode and magnesium acts as oxidation electrode or anode. So here oxidation takes place on magnesium, and on She it is the reduction, because it is the cathode with higher potential. So while representing or using a notation, a cell should have anode on the left and cathode on the right. Let's see how. So in this case, magnesium is the anode, and we have to write it on the left as an oxidation reaction, Mg first, then it gets oxidized as Mg2 plus separated by a vertical line, followed by salt bridge, then the cathode. In the cathode, the oxidized part is reduced to H2, H plus to H2, but H2 cannot stay by itself, it is supported by an inert electrode. So inert electrode is written at the end. Why? Because the surface is shared by the reduced part, not by the oxidized part. So platinum should share the surface with H2. Now what happens if She is acting as an anode? Let us see. I am connecting now She with silver. This is another cell where one half is silver and the other half is She. Since silver is having higher electrode potential, silver will be the cathode and She will be the anode. So while representing, you have to represent She first. Here when it was cathode, you have to represent She second. So in this case, since it is an anode, you have to represent She first while representing this shell. Let's see. First you have to write, in the case She, we have to write the reduced part. When you write reduced part, then you have to write oxidized part. So when you write reduced part, you have to write platinum along with it. When you write platinum, it should share the interface with H2 and not with H plus. So you have to write, for that you have to write platinum first, then H2, followed by H plus, then salt bridge, then the cathode. Cathode in its reduction reaction, as its reduction reaction, Ag plus to Ag. So now a question, what is the difference between reactive electrode and inert electrode? Reactive electrode are those electrodes that take part in the reaction, whereas inert electrode are those electrodes does not take part in reaction but support the reaction. So inert electrode provide their surface and conduct electrons without taking part in the reaction. Platinum and gold. In most cases it's platinum, because even gold is there in the electrochemical series. So it is most time it is platinum. Occasionally use gold. But active electrodes, there are electrodes, for example given here, copper, zinc, silver and lead, which take part in the half reaction, and which is a part of the cell reaction. Now we are going one step closer to the electrochemical series. So this is the electrochemical series. Instead of providing a list, it will be always convenient to have values for each half cell. So while looking into the values, you can easily say that one electrode is having higher or lower electrode potential. So for comparing the electrode potential, it is always convenient to have values for each electrode or each half cell rather than having a list of it. But there is a problem. If I want to find out electrode potential of a cell, of a half cell, it is not possible, because potential of an electrode cannot be determined. Potential means it's the total energy of that electrode or half cell. It is not possible to determine the potential of an electrode, or E0 electrode cannot be determined. But one thing what I can do is, I can find the difference between the two. For instance, in the second part we saw difference between the electrodes in Daniell cell, copper and zinc. Difference between copper and zinc was 1.1 volt, and it was shown by voltmeter. So difference can be calculated, and that difference is shown by voltmeter, and that difference is called E0 cell, voltage of cell, potential difference between cathode and anode, E0 cell. So you can write E0 cell is the potential difference between E cathode and E anode. Now how can I find the values using this equation? You have E0 cell, that is the voltmeter reading. Now what you are going to do is you are going to fix one electrode and its value. You are choosing one electrode as a reference electrode and I am going to fix its value. Here I am going to choose hydrogen electrode, standard hydrogen electrode as a reference electrode, and I am fixing its value as 0 volt. So reference electrode is She, and I have chosen She as a reference electrode, and I am fixing its value as 0 volt. I have given its value 0 volt. It's not its actual value, but I am assigning it 0 volt. This is just to fix or assign values for other electrodes, that is above and below it. So the electrodes above it should have a value greater than 0 and below it must have a value less than 0, isn't it? Because as we go up, electrode potential increases. That means value of this electrode must be higher than 0, positive values, and value of this electrode that is below She must be negative value. Okay, while doing this now I have E0 cell from the voltmeter, E0 either cathode or anode. So what I am doing is, when I took She, when I take She as a reference electrode, I always prefer it as anode. Whenever I am using She as a reference electrode, I consider it as an anode. So now I have the value of anode. That what is it? 0 volt. Then you can find the value of E0 cathode. Let's see how. So reference electrode She is always treated as anode whenever it is an reference electrode. What is a reference electrode? It is the electrode used to find the E0 value of other electrodes. So let's see how we can assign the values. I have already assigned the value 0 for She. Now I am first trying to find the value of fluoride electrode using She, fluoride, which is of the highest potential. Now I have 2 half cells. While doing that, I must choose She always as anode. This is what we have to keep in mind. Now I connect this using an external wire that contains a voltmeter. So voltmeter will show a deflection or the potential difference, and it's called E0 cell, and that voltmeter was 2.87 volt. The potential difference between these two electrodes was 2.87 volt, and it's called E0 cell. What is the equation? E0 cell is equal to E0 cathode minus E0 anode. I have got E0 cell, and the E0 anode is hydrogen She electrode, and its volt is 0. So you substitute for that values. 2.87 volt is equal to E0 cathode minus 0 volt. Then what is E0 cathode? That is 2.87 volt. Now fluoride has a value. This is not the original value, but a value that is obtained by comparing it with, or a reference value. How did you get the reference value? By fixing the value of She as 0. So value 2.87 means fluoride electrode has a potential 2.87 higher than that of She. Similarly, I can find the values for each electrode. Each time I have to connect to each half cell, silver first, looking into the voltmeter, doing the same procedure. Then this, and how I got the values like this: 0.8 for silver, 0.77. So you can see as we come down, the electrode potential decreases. These are the values obtained from voltmeter after connecting to She. Now I am going to the half cells below She. First one is iron. So for that I connected She with iron. Then I connected them, and I looked into the voltmeter reading, and I found that the voltage difference is minus 0.44 volt. Why? Because it is this one I am taking it as anode, but the actual reaction is cathodic reaction, so it is reduction here, but I am treating it as anode for finding this E0 value. So automatically voltmeter will show a negative deflection, that is 0.44 volt. Similarly, I can connect She with other electrodes, and each time I can find the E0 cell value. Now in this case, E0 cell is equal to 0.44 volt. So when I substitute E0 cell in E0 anode, E0 cell is this value, and for anode it is 0 because I am treating She as reference, and therefore E0 cathode is equal to minus 0.44 volt. Each time I am doing the same for all, and I will get the values like this. For this it is 0.44, and as we go down, the values decreases. So as a whole, if you see, that value is increasing, electrode potential is increasing. So for each half cell, that value means that is the difference between standard hydrogen electrode and that particular electrode. So minus 0.66 means, with reference to hydrogen, aluminium's potential is potential of aluminium electrode is 1.66 value lower, volt lower. So that's the meaning. So as I said in the last part, these are the half cells that I picked randomly. This is not a complete list. In NCERT they have a much bigger list. So these are the half cell that is given in the NCERT textbook. You can see here our first electrode that was provided in my list, fluoride, that is oxidized part plus electron giving reduced part, and its E0 cell, that is 2.87. After that there are lot of other half cells until we reach the second cell in my list, that is silver, that is 0.8 volt. So there are a lot of other redox half cells or redox half reactions that is known. Even this list is incomplete. If you look into the internet, this list is such a big list, and they have assigned for almost all the redox half cells. Where is hydrogen? You can see the 0 value here. From 0, if you look to the top, you can see that the values keep on increasing, whereas from She, if you look down, the values is decreasing, and the least value is for lithium, which was in our list, and also the highest value is for fluoride. So I have seen these values, and now I am going to verify whether I will get the same values that I saw in E0 cell. For example, in the case of Daniel cell, what was the E0 cell that was shown by voltmeter? It was 1.1 volt. So voltmeter, it showed 1.1 volt. I hope you remember this from the part 2 of this chapter. Now from electrochemical series, I am going to see whether I will get the same value. So what is E0 cell? E0 cell is E cathode minus E anode. What was the cathode in Daniel cell? It was copper. And what was anode? It was zinc. So it is E0 cell is potential of copper minus potential of standard potential of zinc. Now I have the values for this right now, and that is 0.34 for for copper, and anode. Zinc has a potential of minus 0.76. So I am substituting for the values of cathode and anode here. So E0 cell is 0.34 volt minus of minus 0.76. So E0 cell will become 1.1 volt, and this corresponds to the voltmeter reading that we have obtained. Now we'll look into a problem. Calculate the E0 cell of the cell where iron electrode is the anode and silver is the cathode. So in cell notation, anode will be always placed on the left and cathode on the right. Question is also provided with E0 of silver and E0 of iron. For silver it is 0.8 volt and for iron it is minus 0.44 volt. So from the values itself it is clear that the one with higher potential is cathode and one with lower potential is the anode, and also from the notation. So cathode is silver and anode is iron. What is E0 cell? E0 cell is equal to E0 cathode minus E0 anode. So cathode is silver, so you can substitute E0 silver minus E0 iron, and if you are substituting into this equation the values, E0 values of each electrode, you will get E0 cell is equal to 0.8 volt minus of 0.44 volt, and E0 cell is equal to 1.24 volt. So the next question is, construct a galvanic cell and find its E0 cell. You are provided with E0 value of two half cells. E0 sodium electrode, which is equal to minus 2.71 volt, and E0 nickel electrode, which is equal to minus 2.25 volt, minus 0.25 volt. So for sodium it is minus 2.71 volt and for nickel it is minus 0.25 volt. So I have to construct a galvanic cell. For galvanic cell I must have a cathode and a anode, and I should know the reaction. So I have two cells and their E0 values. I have two electrodes and their E0 values. So which one will be the cathode? One with higher reduction potential will be the cathode. So if you look into the values, it is clear that nickel is having higher value, E0 value, so it will be the cathode, whereas sodium is having lower E0 value, so it will be anode. So first thing is identifying cathode and anode. So anode is sodium and cathode is nickel. Now next is to write the reactions. On the anode it is going to be oxidation reaction. So if you write oxidation reaction, Na is oxidized to Na plus with 1 electron, and on the cathode it is reduction reaction, Ni2 plus 2 electron giving Ni. So oxidation reaction is the opposite because anode is represented as a reduction reaction, Na plus 2 oxidized to, so oxidation will be the opposite and reduction will be the same reaction that is given in the notation, that is Ni2 plus 2 electron giving nickel. Since there are 2 electrons involved and here there is only 1 electron involved, I have to equate it by multiplying this oxidation reaction with 2. So the net reaction will be adding up all the reactants, 2Na plus Ni2 plus giving nickel plus 2Na plus. So what is E0 cathode? E0 cathode is minus 2.5 volt and E0 anode, because sodium is the anode, is minus 2.71 volt. So we have the formula: E0 cell is equal to E0 cathode minus E0 anode. Cathode is nickel and anode is sodium. So substituting the value, minus 0.25 volt minus of minus 2.71 volt. So you will get 2.46 volt from this cell between sodium and nickel. So in this slide we have some selfie questions is E4. What you have to do is pause the video and read the questions carefully and try to answer it. Answer it in a piece of paper, and once you finish answering, you come back, resume the video and evaluate your answers. Okay, the first question is, comment on the differences between the electrodes in these two half cells. So two half cells is given. First one is silver and the next one is, you can see it here, it is She electrode or She half cell. So what's the difference between the electrode in these two half cell? Here in the silver it is Ag and in She it is platinum. That means Ag has a reactive electrode and platinum has an inert electrode. So that's the difference. Ag will get reacted, whereas platinum in She will not get reacted. It just supports H2. Next is write the reduction, oxidation and net reaction taking place in the following cell. The cell is given. First the anode part, that is lithium, then the cathode part, it is copper. So oxidation is taking place in lithium electrode and reduction is taking place in copper. Then we have to write the net reaction. Same oxidation in lithium giving oxidizing to Li++ electron, whereas copper is reducing by accepting 2 electrons to Cu. Since there are 2 electrons, I have to equate this equation into 2 electrons, so multiplying with 2. Then write the net reactions, 2Li plus Cu2 plus giving 2Li plus Cu. Now the third question, calculate the E0 cell of the reaction of this cell. In this cell we have aluminium as anode and silver as cathode. They have given E0 of each electrode. Aluminium electrode, it is minus 1.66 volt and for silver it is 0.8 volt. So cathode is silver because of its higher potential and it's given in this cell also, notation also, and aluminium is the anode. So if you look, E0 cell is equal to E0 cathode minus E0 anode. Cathode is silver, so its potential is written first 0.8 volt minus 1.66 volt of aluminium, that is anode. Finally you will get the voltage of cell is 2.46 volt. Next question, what is reference electrode? Reference electrode, in our case it was She, or in the case of electrochemical series it's She. She is used as a reference electrode to fix the value or assume the value of other electrodes, that is above and below it in the list in the series. What is its E0 value? Its E0 value is 0 volt. It is assigned 0 volt. Okay.